All right, next up we have Edgar from PDT Partners. And the clicker should be the big buttons.
Hi. Hello, everyone. My name is Edgar. I want to introduce Nix Ninja to you to bring you incremental builds using dynamic derivations. So first of all, why is it called Ninja? Well, Ninja is an existing build system that Google created over a decade ago to essentially build Chrome really, really fast. In fact, it was so fast that other projects like Meson and CMake targeted the Ninja format, ran Ninja as a sub-process, and then essentially delegated away the incremental building piece. So because it's kind of an abstraction, it kind of became a standard of its own. And other people will start writing drop-in replacements for Ninja with different goals in mind. Google, for example, released CISO recently, which is a drop-in replacement for Ninja, targeting some of its remote build protocols. So Nix Ninja is a drop-in replacement for Ninja, but targeting Nix as a backend for incremental builds. To walk you through the project, I want to quickly show you a Ninja file, and it's pretty simple. They're just rules and builds. So here you have a compiler rule that tells you how to compile. You use a compiler rule to compile an object file, a linker rule to link it into a final executable, and that's pretty much it. This is all machine generated by higher level build systems like Meson and CMake. And it kind of looks like a make file, it's quite readable. But I think this distinguishing factor is that it's quite explicit about what is the input and what is output syntactically, which means that comes in pretty handy when translating to Nix. So when you have multiple inputs to a build step, you get a graph, and Ninja knows how to run this in parallel. It tracks M time on source files to figure out what to rebuild. What Nix Ninja does is it generates a derivation for every build step and adds source files to the Nix store. And Nix already knows how to rebuild what has changed. So then, ta-da, you have incremental builds. Obviously, there's devil in the details, but that's pretty much how it works. But we can also lean on Nix for its caching, scheduling, and remote build protocols. So does it work? So Nix Ninja can incrementally compile CppNix today, end-to-end, and the final executable works. But we haven't done any optimizations yet. You can see there's an overhead, but I think it's a good start. So it leverages experimental features, CA derivations for early cutoff. Dynamic derivations basically allows us to avoid IFD. And recursive Nix, I know, is a bit unpopular, but I think there's work in issue 8602 that may make progress in this space. I think the really exciting thing about dynamic derivations is that it does not block the evaluator. It has no IFD. So it means that tools like Nix Ninja has a potential path to be used in Nix packages to compile really massive projects like LLVM and Chromium. Anything that uses Meson or CMake. In fact, I think anything that can output a Ninja file, like maybe Lang to Nix implementations, can also just use the same tool and not directly integrate with dynamic derivations. I think another thing that's really exciting is that I think dynamic derivations finally brings Nix to the same playing field as other cloud distributed build systems like Bazel and Buck2 in the way that Google and Meta uses them. These days we have excellent remote Nix build farms like NixPol.net. So I think things are finally coming together where it all works and maybe Nix becomes the one-stop shop. I'm a big fan of reducing complexity, so I'll very much not like to use Bazel and Nix together just to get incremental builds and just use Nix as the one solution. And I think we are starting to see a possibility to getting there. That's it. I'm around in the workshops tomorrow, so If you want to hack on Nix Ninja or you want to just chat about it, come find me there.